So good morning, welcome to EduMath Zone. So welcome to the 10th standard classes. So now we have been discussing revision classes. So that is the first chapter, real number chapter. So yesterday we had a discussion up to, yes, 1 minute, let's wait, 12 problems. Now 13 problems onwards we shall have a discussion. See 13th problem. So let me write on the screen. See, find HCF and LCM of the following using prime factorization method. Prime factorization method. This is one of the methods to find out. So, good morning all. Good morning Monica. Good morning Anish. So first question is 12, that is 15, 21. So we need to find out SCF and LCM using the prime factorization method of these three numbers. How could you find out? The plan is first like this. Plan. First express 12, 15, 21 as product of primes. Product of primes. Product of primes. After that, first find LCM, sorry, SCF, highest common factor. Next find LCM. So first let us write 12 the five prime factors. Prime factors means you can write like this. See 12, 2 6 ja, 2 3 ja. So that means 12 can be written as like this. 2 into 2 into 2 into 3. This we can write 2 square into 3 raised to power 1. Next now take 15. 15. The 15 can be written as like this. 15 cannot be divisible by 2, so try with 3. 3 5 ja, that's all. So 15 is equal to, you can write 3 power 1 into 5 power 1. Next 21. 21 divide with 3, 3 7 ja. So 21 equals to, we can write 3 power 1 into 7 power 1. This is called prime factorization. After that we need to find out SCF and LCM. First now solution you write down like this. So 12 is equal to, first step, 2 square into 3 power 1. So 15 we can write 15 is equal to 3 power 1 into 5 power 1. Next 21 equals to, you need to write 3 power 1 into 7 power 1. Next highest common factor. So we need to write highest common factor SCF. SCF is equal to, what we need to write here, common common number and least power you need to take. Common number is 3, 3, 3. Least power 3 power 1. So that means you need to round up this one. 3 power 1, 3 power 1 and 3 power 1. So that means you will be getting 3 power 1, that is 3. SCF is 3. Next you need to find out LCM. LCM means, again you write down 12 is equal to 2 square into 3, 3 power 1. Next is 15. 15 can be written 3 power 1 into 5 power 1, 3 into 5, 15 only. 21, 3 power 1 into 7 power 1. Next, LCM. LCM is equal to, here common, you need to take common as well as other factors also we need to take. So what is the common you see here? Common is 3 power 1, 3 power 1, 3 power 1 and 3 power 1 right now into, and remaining also 2 square, 5 power 1 and 7 power 1. So 3 power 1 is 3, 2 square is 4, 5, 7 power 1 is 7. So 3 into 7 is 21, 5 into 4 is 20. Now 21 into 20 you need to do. 0, 2 1 ja 2, 2 2 ja 4. 0, 2, 420. So 420. This is the LCM. Good morning, good morning. Right. This is first question. Let us go for the second question now. Second question. 2 cube into 3 cube, already they have expressed as the product of the primes, and 2 power 4 into 3. Now solution. First let us find out HCF. So here given number is 2 cube into 3 cube. Next is 2 power 4, 3. Now SCF. SCF means, so just look for the common factors. What are the common factors? 2 cube is there, 2 power is there. 3, 4, least power is 2 cube. So 2 cube you take it. 3 cube, 3. 3, 3 a common. Here least power 3 power 1, 3. So SCF is equal to 2 cube into 3. So 2 cube is 8, 8 into 3. Answer is 24. This is SCF. Next LCM you need to find out. LCM means, again write down 2 cube into 3 cube, 2 power 4, other number 3. So LCM is equal to, what we need to write? Now common highest power you need to take. 2 power 4. Here highest power 3, 3 common, 3 cube you take it. So you need to write 2 power 4 into 3 cube. 2 power 4 is equal to 2 into 2 into 2, 4 times. That is 16. 3 cube is equal to 3 into 3 into 3, 27. So 27 into 16. 6 7 ja 42. 6 2 ja 12. 12 into 4 is 162. Next 27. Adding 2. 7 plus 3 13. 1 4. 432. So 432 is the LCM. 432. SCF is 24. LCM is 432. Next, go to third problem. Third problem. 24, 36 and 40. 24, 36 and 40. Find the SCF. Lakshmi, welcome. And Monica, welcome. 24, 36 and 40. First let us write 24 prime factors. Okay, now 2 12 ja, next 2 6 ja, next 2 3 ja. So 24 equals to, we can write 2 into 2 into 2, 3 times 2, 2 cube. 3 is only one time, 3 power 1 right now. Next 36, 36 prime factors. How to write? 2 18 ja, next 2 9 ja. Now 9 cannot be divisible by 2. Try with 3. 3 3 ja. So 36 equals to 2 square into 3 square. Next 40. Prime factors of 40. 40 means 2 20 ja. Next 2 10 ja. Next 2 5 ja. So 40 is equal to, we can write 2 cube into 5 power 1. So now write down here 24 equals to, we can write 2 cube into 3 power 1. Okay, this is 24. 36 equals to, we can write 2 square into 3 square. Next 40. 40 equals to, we can write 2 cube into 5 power 1. Okay, now here to find out LCM, common, you check it now. 2 cube, 2 square, 2 cube. Here 2 is the prime, is common. Common means out of this common, least number you need to select. Least means here 2. 2 square. Just round up. So SCF is equal to 2 square. 2 square is equal to 4. Now you need to write LCM. 24 equals to 2 cube, 3 power 1. 36 equals to 2 square into 3 square. 40 equals to 2 cube into 5 power 1. Now LCM. LCM is actually what we need to do first. Common. Common means 2 cube, 2 square, 2 cube is common. In 24 is there, 36, 40. But highest out of this one, 2 cube is the highest. 2 cube. But here 3 power 1, 3 square. Highest 3 square. And 5 power 1 also you need to consider. That means 2 cube. Out of 3 power 1, 3 square, highest is 3 square. 3 square into 5 power 1. So that means 2 cube is 8, 3 square is 9 into 5. So 8 9 just 72, 72 into 5. So 72 into 5 means 5 2 just 10, 35, 35 plus 1, 36, 360. So this is equal to 360. HCF is 4, LCM is 360. Next 14th problem. So are you there, all of you? Are you there? Watch till the end of the session. Using Euclid's division algorithm, find the HCF of the following First question, 96, 72. So here we need to find out the HCF of highest common factor of two numbers using condition Euclid's division algorithm. We need to use, not prime factorization. The first method, Euclid division algorithm, we need to find out. To find out SCF of 96 and 72. First, just check 96 and 72. 96 is the larger number than the 72. So first 96 is divided by 72 right now. 72 2 ja, it will be more. 72 1 ja 72. You will be getting, subtracting 4, 24 you will be getting. So solution, first we can write like this. 96 equals to multiply 72 and 1, add 24. You get same 96 only. 72 plus 24. So 96. Say equation 1. Again, what shall you do now? Again, you need to apply on 72 and 24. 72 divided by 24. So how long shall we continue? Till we get the remainder 0. 24 3 ja 72. 0. Stop. So that means again this 72 equals to this 72. This 72 can be written as, so this 72 can be written as 24 times 3 plus 0, say equation 2. So now this 24 is the LCM. This 24 is the LCM. Sorry, SCF, common factor, highest common factor. Therefore, SCF of 96 and 72 equals to 24. Very simple method. This is Euclid division method. I hope you might have understood this one now. Now the second question. 324 comma 218. SCF of these two numbers using Euclid division algorithm we need to find out. So what shall we do now here? What shall we do? So that means we need to find out, first of all, here 324 is greater than 218. So 324 divided by first step 218. 218 1 ja 218. Subtract. It cannot go. Borrow 10. It becomes 11. It becomes 2. So 14 minus 8, 6. This is actually, you will be getting 1. Sorry. This becomes 1. 1 minute. 1 minute. I will check it now. 324 divided by 218. 218 1 ja 218. So it cannot go now. Borrow 10. It becomes 1. 14 minus 8 is 6. 1 minus 1 is 0. 106 you will be getting. So that means first step, you see, what do you write? This 324 we can write 324 equals to 218 into 1 plus 106. Just multiply these two and add this remainder. This is called remainder. So you will get same 324 only. Now this is first. Apply the same division on 218 and 106. 218 divided by 106. So 106 2 ja 212. You will be getting 6. So that means 218 equals to, you can write 106 times 2 plus 6. This is 2. Now 106 divided by 6. 6 1 ja 6. 46. 6 7 ja 42. So you will be getting 4. Okay, you will be getting 4. So that means again this 106 can be written as 6 times 17 plus 4. Again on 6 and 4 you need to apply. 6 divided by 4. 4 1 ja 4. So 2. You will be getting 2. So that means 6 can be written as 4 into 1 plus 2. Say this is equation 4. Again you need to apply on 4 and 2. 4 divided by 2. 2 2 ja 4. Stop. 0 LCM you will be getting. So 4 equals to, you can write 2 times 2 plus 0. Say equation 5. Now this 2 is the HCF. Therefore HCF of 324 and 218 equals to 2. This is the answer. This is the answer. Are you there, all of you? Yes or no? You need to chat, all of you. Lakshmi, Ganesh, Monica, others also. I have taken the attendance now. This is 14th one. Now the 15th question. 15th question. Yes. Very good, very good. Solve the following. Solve the following using logarithms. Using logarithms. So we need to solve the following using logarithms. Now 1, 2, Lakshmi, Yadav and Monica, 3 members. Okay, right. Solve the following, use the logarithms. So first one, 2 to the power of x plus 1. This is 2 to the power of x plus 1 equals to 3 to the power of 1 minus x. So you need to solve this equation. This is called indices equation, index equations. So you need to solve it now. Solution. What is given actually here? Here given is 2 power x plus 1 equal to 3 power x 1 minus x. Apply logarithms on both sides. Logarithms on both sides. Apply logarithms on both sides. So that means you can write the next step is like this. Log of 2 power x plus 1 equals to log of 3 power 1 minus x. See, you need to follow how I am going to read all these things also. Log of 2 power x plus 1 equals to log of 3 power 1 minus x. You repeat yourself also after me. So next, see, we have one important formula. What is the important formula? Since x, this is called power rule. Log x to the power of n to the base a equals to n times log x to the base a. N times. So this we can write x plus 1 into log 2 equals to, this becomes 1 minus x into log 3. Now multiply x plus 1 with log 2. You get x into log 2, x log 2 plus log 2 into 1 log 2 equal to log 3 into 1 log 3 minus x log 3. Here, so let us bring minus x log 3 this side, log 2 that side. So if you bring minus x log 3 this side, it becomes positive. So we get like this, x log 2 plus x log 3. This equals to log 3 minus log 2. Now we can take x common out from these two. So Giri Yadav. So x common if you take x common, you have log 2 plus log 3 equal to log 3 minus log 2. So we need to write x value. So x is equal to, answer is log 3 minus log 2 upon log 2 plus log 3. It's completed. This equation has been solved. This is the answer. Next, let us move to the second question in this one. Second question. What is the second question? 3 raised to x equal to 5 raised to x plus 2. How could we solve? Do we have any idea? What shall we do? Apply logarithms on both sides. Then given data write down. If you write the given data also, you will get marks in the examination, my dear students. Please remember. What is the step you will get it? Solution. Here given. What is given? 3 raised to x or 3 power x equal to 5 raised to x plus 2 or 5 power x plus 2. Apply logarithms on both sides. Apply logarithms on both sides. This is the second step. So now what is the next step? Logarithm of log of 3 power x equals to log of 5 power x plus 2. So then Giri, note down, log x to the power of n to the base a is n times log x to the base a. This n into this one, n times log x this base a. So that we can write here x times log 3 or x into log 3. This is x plus 2, put the bracket because 2 terms we have, into log 5 or x plus 2 times log 5. Yes, here this is x log 3, x log 3, x into log 5 plus 2 log 5 plus 2 log 5. What shall we do? Take x log 5 this side. So then you get like this step. X log 3, that is called transposing. Transposing x log 5 this side, we get x log 3 minus x log 5 equal to 2 log 5. But we need x value. So let us take out x common. If you take x common, what do you get now? Log 3 minus log 5 equals to 2 log 5. Now our aim, what do you find? Yes, therefore x equals to 2 log 5 upon or divided by log 3 minus log 5. Yes, completed step this is. So don't put Giri like that symbols. So this is next. This is 15th question. Now 16th question is very important. 16th question is very important question. Very important question. Expected question in the examination. Expected question in the examination. See, show that following are irrational. First question is root 3. The question may be like this. Show that root 3 is irrational. This is very important. So I will discuss this question. First, let us assume that root 3 is irrational. Root 3 is irrational. You can create your own questions also like this. Prove that root 2 is irrational, root 5 is irrational, root 7 is irrational, root 11 is irrational. You can do the same method. Let us assume that root 3 is here not irrational, say rational. For example, we need to prove irrational, say rational. This is the first step. This is called proof of contradiction method. Let us assume that root 3 is rational, and let us suppose that root 3 equals to a by b, where a comma b are co-primes. Co-primes means SCF of highest common factor of a comma b is 1. Don't put Giri those symbols, don't put it. Right. So now we have root 3 equals to a upon b. Cross multiply. What do you get? Root 3 times b equals to a. Now squaring on both sides. Next step. Squaring on both sides. Squaring on both sides. So note down all of you. Vijay Swarupini. Good morning. Welcome. Here we need to write like this also. One more thing. B does not, sorry, 1 minute. B does not equal to 0 or co-primes. A comma B does not equal to 0 or co-primes. Squaring on both sides. Squaring on both sides means you get like this. Root 3b whole square equal to a whole square. So now what do we get? Root 3 whole square is 3b square equal to a square. So 3b square is equal to a square means 3 divides a square. So that implies 3 divides a. This is very important step. Say equation 1. Now consider a equals to 3 divides a. So that means actually a is equal to 3 times c right on, because 3 divides a means 3c. For example, 2 divides a is equal to 2c. 5 divides a is equal to 5c. Like that you need to write a is equal to 3c. Put this a is equal to 3c here in this step. So now substituting a is equal to 3c in 3b square equals to a square. That implies what do you get? In the place of this a, write down 3c. 3b square equal to 3c whole square. This is 3b square equal to 9c square, you will get it. So b square equals to 9c square by 3. So now we get b square is equal to 3c square. B square is equal to 3c square means actually here b square is equal to 3c square. 3 divides b square. We need to write 3 divides b square. 3 divides b square means that implies 3 also divides b. Say equation 2. So therefore 3 divides both a and b. But according to our assumption, our condition, HCF co-primes means here actually HCF of a comma b is equal to 1 only. But here HCF of a comma b becomes 3. It is a contradiction. It's a contradiction. So now this is a contradiction. This is a contradiction. Contradiction. Therefore, our assumption is wrong. Our assumption is wrong. Our assumption is wrong means, what is our assumption? We said rational number. So it's wrong. Wrong means root 3 must be irrational. So hence root 3 is irrational. So my dear students, actually yes. My dear students, all of you take, already I proved root 3. You take root 2, root 5, root 7, root 11. Prove that they are irrational in the same method. If you have any doubt, you can clarify with me. Now the second question. 5 plus root 2 is very simple. We need to prove that 5 plus root 2 is irrational. See, first we need to write like this solution. Let us assume that 5 plus root 2 is rational. This is our statement. So now let us suppose that 5 plus root 2 equals to a by b, where a comma b does not equal to 0 or co-primes. Okay, take 5 that side. So we get root 2 is equal to a by b minus 5. What do you write here? This root 2 equals to, here LCM is b, a minus 5b. Here a minus 5b and b are rational. Then a minus 5b by b is also rational. But root 2 is not rational, irrational. Therefore, we are getting irrational is equal to rational. See, a minus 5 is rational, by rational, but root 2 is irrational. Irrational cannot be equal to rational. Therefore, it is a contradiction. So our assumption is wrong. Our assumption is wrong. Our assumption is wrong means this 5 plus root 2 must be. Hence 5 plus root 2 is irrational. Hence it is proved. Yes, root 2 is irrational. Now we need to write one more step also here. I will add like this. Since root 2 is irrational, so irrational is equal to rational. It is a contradiction. It is a contradiction, or it leads a contradiction. So our supposition is wrong. Our assumption is wrong. Assumption is wrong. Hence 5 plus root 2 is irrational. Very good, Lakshmi, very good. So now once again say who are watching now classes. Yes or no? Yes or no? Just type it. You need to type it now. So now the third problem. Third problem. Root 3 minus 7. You need to prove that root 3 minus 7 is irrational. So that means now the solution. Let us assume that root 3 minus 7 is rational. This is the first our assumption. May be correct, may not be correct, we do not know. Giri Yadav, don't put those symbols. If you put that symbols, see, first I will check your notes today. Right. So now let us suppose that root 3 minus 7 equals to a by b, where a comma b does not equal to 0 are co-primes. Co-primes means HCF of a comma b is 1. Okay, now here you do one thing. So take minus 7 that side. So root 3 equals to, you get like this, a upon b plus 7. That is called transposing minus 7 to the right hand side. Now root 3 is equal to, you get here b LCM a plus 7b. So now here see, a plus 7b is rational, comma b is also rational. That implies a plus 7b by b also rational. But root 3 is irrational. Irrational is equal to rational. It's a contradiction. So our assumption is wrong. That we need to write it now. So now a plus 7b comma b are rational that implies a plus 7b by b is rational. Since root 3 is irrational, now we get like this. Irrational is equal to rational we will be getting. So irrational equal to rational. Irrational equal to rational. So our assumption is wrong. Our assumption is wrong. Hence, what is the question? That we need to write. Root 3 minus 7 is irrational. So this method need to be adopted for this problem. This is third problem. Now fourth problem. Fourth problem. Right. Let us move to the fourth problem now. Root 7 plus root 8 is irrational. This question is very, very important. Very, very important. Root 2 plus root 3. These questions may be asked. Root 2 plus root 3. Root 3 plus root 5. Root 5 plus root 7. Or even root 2 minus root 3. Root 3 minus root 5. Or root 5 minus root 7. All these questions will come out. Or root p minus root q. Root p plus root q. Prove that all are irrationals. All are irrational. This model is very important. Okay, let us solve now. Let us solve. Very good, very good. Lakshmi, Swarupini is there. Maunika, Ganesh. Right, Vijay Swarupini. Solution. So let us do like this. First, let us assume that, assume means just considering, assume that root 7 plus root 8 is rational. This is the first step in all these problems. This is the first step, very simple step, everybody will write it. Yes, Giri Yadav, like that you need to chart. Let us suppose that root 7 plus root 8 equals to a upon b or a divided b, where a comma b does not equal to 0 or co-primes. Co-primes means SCF is 1, highest common factor is 1. Now once again consider root 7 plus root 8 equals to a upon b. Squaring on both sides. This is important step. Squaring on both sides. Squaring on both sides. Squaring on both sides means root 7 plus root 8 whole square equals to a upon b whole square. Don't worry, I will explain how to square. Varikuppala Ramu, late. So root 7 plus root 8 whole square. This is root a plus root b whole square or a plus b whole square formula. What is a plus b whole square formula? A plus b whole square equals to a square plus 2ab plus b square. With the help of this formula, we need to expand this one. This is the formula. Okay. So now we can write. So that implies root 7 whole square. A square means plus 2ab. 2 times root 7 times root 8 plus root 8 whole square equal to a square upon b square. A by b whole square means root 7 whole square is 7. This is very important step. 2 times Root 7 into root 8. Don't worry. Root A into root B means root of A into B. Root of AB. So this is root of 7 into 8. Root 56. Plus root 8 square. 8 equal to A square upon B square. Now you can add these two. You can add these two. 7 and 8 you can add. So now what do you get? 7 plus 8 is 15 plus 2 root 56 equals to A square upon B square. Now transpose 15 that side. 2 root of 56 equals to, you can write A square upon B square or A square by B square minus 15. Let us simplify it now. 2 root 56 equals to, here B square is the LCM. See, you go back once again. B square into 15, 15B square. So we get A square minus 15B square. It is very clear that A square minus 15B square is, A square minus 15B square is a rational, B square is a rational. Write down here. A square minus 15B square comma B square are rationals. Rational. That implies A square minus 15B square by A square B square is also rational, or is rational, no problem, is rational. But sorry, you can write this also. 1 minute, root 56 only you can write. So that is 2B square. Here 2B square write down. 2B square is rational, but root 56 is irrational. So that implies we have like this. Irrational is equal to rational. Never, irrational cannot be equal to the rational. So it is a contradiction. It is wrong. That means it is a contradiction. Contradiction means it is ambiguity. Contradiction. It cannot be possible. That means it's a contradiction. So our assumption is wrong. Our assumption is wrong. Our assumption is not correct. Incorrect. That means what is our assumption? Our assumption is root 7 plus root 8 is rational. It is wrong means it is not rational. Not rational means irrational. So hence root 7 plus root 8 is irrational. Like this you need to prove it. Okay, Ganesh. 17th question. Write the following. Write the following in single logarithm. That means express the following as a single logarithm. See the first question. 2 log 3 plus 3 log 5 minus 5 log 2. Express 2 log 3 plus 3 log 5 minus 5 log 2 as a single logarithm. So now see the solution. Whatever given, write down. 2 log 3 plus 3 log 5 minus 5 log 2. In logarithms, we have one formula. What is the formula? See, n times log x to the base a equal to, take power back. Take power back. This becomes log x to the power of n to the base a. Log x to the power of n to the base a is n times log x base a. N times log x to the base a. We need to read like this, log x to the base a. That is log x to the power of n to the base a. This we can write taking power back, log 3 square we can write, plus this we can write log 5 cube minus this we can write log 2 power 5 using this rule, power rule. This is called power rule. Okay. Vijaya Swarupini, are you there? Right. This equals to log 3 square is log 9 plus 5 cube. 5 cube is 5 into 5 into 5. 125. Log of 125 minus log 2 power 5. 2 power 5 is 2 multiplied for 5 times. That is 32. First take the first two terms. These two terms. So these two terms are in the form of log x to the base a plus log y to the base a. This is a formula. This we can write log of xy, product of two numbers, to the base a. So that means log of 9 into 125 you can write. So this next step is log of 9 into 125 and minus log 32. Now 125 into 9 you need to multiply. So now 125 into 9. 9 5 ja 45. 9 2 ja 18. 18 plus 4 is 22. 2 note down. 9 1 ja 11. 1125. This is logarithm of 1125 minus log 32. How does it appear? Yes, here we have one more formula. Log x to the base a minus log y to the base a equal to log of x by y, not x into y, to the base a. So this we can write as a single logarithm. Now log of 1125 upon 32 or by 32. This is the answer. So in this way we can express this one as a single logarithm. This is called single logarithm. Understood now? Log 1125 by 32. Very good, Vijaya Swarupini. I hope you might have understood this one. So okay, tomorrow we shall continue in the same session. Thank you. Bye bye. All of you practice all these questions once again. Even revision 1 and revision 2 also. Bye bye. See you. Have a nice day.